Testing, 1 2 1 2. Am I going live? I'm pretty sure I am. Although I have comments turned off on this one, but actually maybe I could turn them on. Just give me a second. Depends how many people are going to be here. If there is anyone out there watching the stream now, when I look that way, it means I'm looking at the comments. Is the live chat enabled now? I think I just enabled it. So if anyone's there watching, I can see there's at least a few people there watching right now. Can you say hi in the chat? Just want to make sure that that you can hear me or not. There we go. Okay, so usually I would wait until 5 past, but I realized I don't have that that requirement anymore because the recording is now no longer being done in the lecture theatre. I am now at home and attempting to stay home as much as I can. Someone said the volume is a little bit low, so let me I'll turn up my volume a bit to send out to everyone. Okay, just cranked up my microphone a little bit. Actually, I can probably turn it up even higher than that and see how we go. There you go. So I'm a bit louder now. See if that's okay. Volume is way too low, someone's saying. Let me just make sure that I'm using the right microphone. Okay. How are we doing on volume now? Because I've just cranked it all the way up, and I've made sure I'm using the actual webcam microphone. Okay, so I guess we're in a period of mild disruption at the moment because we are trying to maximize the distance between people and making sure people aren't, in the same room as each other, are not touching each other and things like that. And so one of the measures we can do for that, obviously, is to take a massive group of people, like the COMP1511 lectures, and then just move them into the comfort of your own homes. So some people are going to be here right now in the live stream, and I think other people are just going to use it as a video. And I mean, plenty of people I think were just watching videos and not necessarily going in person to the lectures anyway, which is a doable thing. So thank you everyone for accommodating this. This is also a bit weird for me as well, although I've done some live streaming before, but I've never really done it with proper formal content like we have in the lectures. So what I'm going to do, hopefully, is have the lectures delivered just the same way they would in the 2 hours, and what I will do is every now and then, you can tell when I look this way, because when I look this way like this, I'm looking at my other monitor, and the other monitor has your live chat there. I'm going to leave the live chat on, but I would ask you to treat the live chat the same way that you would treat your hands going up in the lecture theatre. So while I'm lecturing, only post stuff in the live chat if it's explicitly a question about what I'm talking about. And I do have a couple of questions in there as well. Someone's asking, are the comp tutorials still in pairs? We're going to see about that. We're going to at least try to keep people working with lab partners, but I mean, it's much harder when you're not there physically with each other. The software that universities provided for us, this thing called Blackboard Collaborate, has the ability to work in groups. So you can just have a little group where you and your partner can see each other's screens and stuff like that, but you're not necessarily sharing them with the whole class. So it's possible, but at the moment we're just sort of finding our way around the system. So this week we're going to have the tutors try to do everything remotely, the tutorial and the lab, and we'll just see how well it goes. because I can see a lot of potential issues in that, a lot of things we might need to do that we haven't necessarily figured out yet. So bear with us, because taking a massive course like this and flipping it online in was it 4 days? It was less than 4 days. The only reason we spent 4 days on it is because when the World Health Organization organized a pandemic, my admin Tom and myself decided we should prepare for this because we think we might have to go online, and then the university didn't make the final decision to go online until yesterday in the middle of the day, and so we had the announcement out to you within a couple of hours of our commitment to do that. So, I mean, hopefully this works. Hopefully everyone gets the same information, and that, yeah, and that we still teach everyone everything you need to know about COMP1511. Okay, there's a question there that the Echo 360 stream is not working. That's correct. The Echo 360 stream would require me to be at UNSW, and if you can sort of see the background behind me, the fact that I'm sitting in a chair, I'm actually at home at the moment. I'm not going to go into campus if I can help it. So yeah, the Echo 360 stream will basically be disabled for the rest of the term, unless unless I decide to actually go back in physically and start delivering content in person again, which is unlikely to happen until something changes in the status of preventative measures about spreading the coronavirus and things like that. Okay, let's get into it. Hang on. Here we are on my slides. Oh, well, there's my first problem. I've put my little picture of my face there, and it's covering up some of the slides. Let me just see if I can. I'm just going to move this to somewhere where it's less likely for me to have content. That will probably be okay. Let's see how we go. Okay. So last week we were talking about two-dimensional arrays. So I showed you some two-dimensional arrays, and we looked at the tourist, which was a two-dimensional grid where we could change the numbers in the grid based on where we were moving. We were looking at how to check for hitting the edges or going off the edges of a grid and things like that. So I think you're going to get a fair bit of practice with two-dimensional arrays, because we're throwing you in the assignment with two-dimensional arrays. There's going to be a lot there, so hopefully that example last week was a good starting point for you to then get into the things that are in the tutorials this week, and you can go on to sorry, I'm getting distracted, but yeah, can we please leave the comments to actual questions, right? So yeah, so I think people will have learnt a little bit about 2D arrays, and in the assignment you will learn a lot more about 2D arrays, but not just 2D arrays, but arrays in general and how to work with them. So how we're going to do things like looping through arrays and things like that. We also looked at pointers. So pointers was our first look at this one step further back, thinking about programming. So everything before, when we had a variable, it was like a variable has memory. So somewhere in my computer, there's bits that can be turned on and off for the memory, and they will store values. The difference now is that we have pointers which are storing values. Like, they're just a variable storing values. They're like a 64-bit integer in the way we're using it. But instead of storing a number that we're really going to use a lot, they're storing an address where we're going to follow that address to find another variable. So every pointer, when you think about it, when we create it, unless we create it as null, so remember the null keyword. Actually, I have slides recapping pointers. I should go over them when I'm talking about it, but I'll just finish what I'm saying. When we have a pointer, we'll have the pointer created usually aiming at another variable, and so it's going to give us access to another piece of memory. It's not just the piece of memory that the pointer's in, it's access to another. Okay, Today we're going to have a quick recap of pointers, and I didn't finish all the code from last week, so I'm going to spend the first sort of 10-15 minutes going over the code for the Jumbler and finishing that. And then I'm going to talk about something that I think that a lot of people will probably be getting into at this point, which is debugging. So we've probably been doing a fair bit of this where we've had the idea that there are going to be problems in your code, and the more complex your code is, the harder it is to find out exactly what those problems are and how to fix them. So we're going to have a quick look at that, and some sort of formal techniques in a sense. So I'm going to say, okay, here's a list of steps you can take, and these kinds of things are the things you can do to try to find the problems in your code and try to fix them. So simple things like going through your compiler errors and figuring out how to fix them. Because I think that we're getting to that point now where your programs are big enough that you can't just sort of immediately look at the line number and then find the problem. That you want a technique to finding those problems. Then I hope we have time for this. I put it in the slides, I reckon we will, is we're going to look at a new variable type called a character, and that's a variable for actual letters. And so we're going to move on to being able to create letters and words and things like that. We're going to continue that tomorrow as well, so if I don't finish it all today, we'll still be able to do it. So we had a question there saying, will this lecture still be exactly 2 hours? I will be going between 9 and 11. But what I'm thinking, because I usually have some people that stick around afterwards to ask questions in person in the lecture theatre, and so I'm not going to sort of abandon that. I will probably just keep the stream running in an informal way and see if people have questions in the live chat, and I'll answer those questions after the time. But in terms of the actual presented time and the time you have to, well, you don't really have to, but I mean the time that you're going to want to be here for course content, it'll be 9 to 11, but the actual video will probably be longer because I'll have a longer tail where I actually stop and have a chat with people. Okay, so recap. Pointers. I already have spoken a little bit about this, but pointers are variables, and the value that's stored in the variable is the address of another variable. Pointers also have a type, so pointers will specifically be pointing at a certain type of variable so that when we go through to access it, we know how much memory to grab. So for example, the two types of variables that we've worked with a lot were integers and doubles. And then we've also got variables for arrays now as well. But if we're only thinking about integers and doubles, the pointer has to know whether it's looking at 32 bits of memory or 64 bits of memory, and also what do the actual bits mean. So the bits in an integer are different from the bits in a double. They both represent numbers, but the double also represents the fact that there's a decimal point somewhere, and so you can't necessarily encode the numbers in the same way between the two of them. So with pointers have to know what kind of variable they're going to access if you were to follow the pointer to what it's aiming at and grab that information and use it. So pointers have a type as well. So the trick behind pointers that makes them so useful is that instead of passing around variable values and stuff and saying, okay, here's an integer or something, or here's a double, we're saying, here's the address of that integer or double, which means the integer just exists once in our program, and a function can get access to it by saying, oh, I know where that is, now I can change its memory and stuff like that. We had a question there about if the whole online things persist until exam week, how will finals take place? And there's also a question about help sessions. So a lot of this stuff. Ooh, Alvin's there. Alvin can answer actually some of your stuff. He's one of the tutors. If the online thing persists until exam week, we're going to have to think about that, because I don't really like the idea of online exams, because for us to invigilate it, we might have to look into your home, which is nearly a breach of privacy. It's also really hard to run an online exam correctly. Like when you think about it, we've got the assignments, and the assignments are like you doing a sort of exam, so it's like it's distance. Whereas an exam, the whole point is we throw you into a situation where you don't get any help and you don't get any references or anything like that. You just have to do it yourself just based on what you remember. And unless we can find a way to do that, we may try to just do exams after the quarantine or whatever that happens is lifted. I mean, this is really up in the air. In the next few weeks, this virus, as you've seen in other countries, tends to grow really quickly. So we'll just see what happens. Like, that's the best I can say about the exam at the moment. There's a question about help sessions running online. Help sessions will run online. They're just getting really reorganized at the moment to run online. So we definitely don't want to. We don't. We don't want to make sure that we don't want to put you in a situation where you don't get help. So we definitely want help sessions to be running. And so we're just figuring out what system we're going to use to be able to give one-on-one help with help sessions. Okay, continuing the recap of pointers. One of the ways I like to teach pointers, because I think it's nice to be able to think of them in a physical world context, is I like to think about pointers as if they're street addresses. So if we declare a pointer and we declare a pointer aiming at another variable, that's like me saying, okay, this is the address of the variable. And that's good as well, because memory addresses are also called addresses. We can use the same terminology. So I'm like writing down the street address of something. It's the same way as storing its memory address in a pointer. And we can also ask a variable what its address is. So if we have access to a variable, we know the name of the variable, we can say, hey, can you tell me what your memory address is? I can store this in a pointer. So that's like me going up to a house, looking at the street number on the house, and then writing that down and going, okay, here's my pointer. And my pointer has access to this house, because I could give this pointer to anyone and they'd be able to find this house. So we can think of pointers as being ways to find locations. And then when we want to access a pointer, so the star is in the creation of the pointer. When we then want to access the pointer, we use the star again. So like the square brackets, the star was the ability to create, and then once it's created, it has a different purpose that we can use with the pointer. So the star and the pointer allows it to access the variable that it points at, which means that when we, for example here, put the star in front of the variable, what that does is it takes the address of the pointer and it says, I'm going to go to that memory address, and then I'm going to read whatever information is at that memory address. So I like to think sometimes of the star as Google Maps. So when you've just got a pointer, it is just a memory address. And then when you put a star on it, you're saying, okay, Google Maps, tell me how to find the location that is at that memory address. And then I will go there and I'll read whatever information's there. So the star is like saying, I'm going to go to the house that is at that address, I'm going to open the house, I'm going to look at the information that's inside, and that's what I'm going to see when I've used the star. So just takes a little bit of practice to get a handle on these things, because there's the star symbol, and back here there's the and symbol, and the and symbol is the address symbol. So we could nearly say address instead of and whenever we use that symbol. And the star symbol is the pointer symbol, so it's used to create it, and then it's also used to access whatever it's aimed at. So these are the things that you just sort of got to remember, and once you get a bit of practice with them, you will get this kind of ability to use these two symbols, one to create, one to access, that kind of thing, and then you'll get more comfortable with them. When we use pointers in functions, we basically give access to this function. We can give it access to some variables that we've created. So I have some variables somewhere else. I can pass pointers into the function, or I can pass addresses of these variables into the function. And then the function will have access to these variables that are somewhere else in my memory. So we're going to do a bit of that in the tutorials and labs this week. Actually, I think this one is one of the questions in the tutorials and labs this week, but it's good to get a good idea from the ground up how this stuff is working, and at least just try to remember the basics of how they go. The other thing to remember is that pointers and arrays are actually very similar in certain ways. In certain ways only. Like they're very different in other ways. Like an array says I am a container and I hold multiple variables, and a pointer in no way does that. A pointer just says I'm a memory address. So if I'm a memory address, then somewhere there's a memory that I'm aiming at. Um, but the trick that's interesting is that if we use an array without the square brackets, so if we just use the name of the array, that's actually the memory address of the start of the array, which is really similar to a pointer. I can give you a pointer to the first element in the array, and I can give you the array itself as a variable. So this is if I use the array's name with no square brackets. Then what I'm going to get if I do that is actually the same memory address. So the address of the first element in the array is the same as the value that's stored in the name of the array itself. So that way we can do things like passing an array into a function, and that gives that function access to the array. Okay, so this is the jumbler that we were working on the other day. Let me just fire up Vlab, see where we were up to. Computers a little bit slower from home than it is when you're on campus. I've got a question there is, then why don't we get the address of the variable when we try to print %d star IP, because we are giving star IP the address of the n. I'm going to assume that when you say of the n, you mean the variable itself. Star, if you put a star in front of a pointer, it's going to follow the pointer to whatever it's aimed at, and it's going to grab the value of what it's aimed at. So if you put a star in front of the IP, then you're going to get the value of the variable. If you take the star off the front of the IP, then you're going to get the address. And the %d is going to get confused if you give it an address, because the %d is going to try to do a decimal integer, so it'll probably try to convert that hexadecimal value into a decimal value. Let me see if I've got some code here where I can help you with that. Last one was lecture 8. Did we have a pointers demo? I'm pretty sure I had a pointers demo. Yep. Alright, just going to open that. Just making sure that my face is not covering up any of the code. It's reasonably not covering up any of the code. I'm going to move this over a bit just to make sure. Sorry, my connection's a bit slower from home. Alright, I'm going to wait till that finishes reacting to everything I've just done. This is what I get when I'm using all of my upstream to stream stuff to you while I'm trying to use my up and downstream to get to Vlab at the same time. Oh, come on. This is going to get super annoying, I feel. Come on, finish moving. Someone's noticed that I have the Epic Games launcher in my start bar. I could try just grabbing the code. I don't have DCC set up on my computer here though. and I do want to do everything in the same setups that you have. Okay, it's reacting a bit quicker now. Alright, so when we had these pointers, okay, I'm just going to comment out the array bit that I did down there. So, we're looking at these kinds of examples here with the %d and the pointer. So, if I have an integer I, which has a value of 100, and then I create a pointer IP. So to create the pointer, I have to put the star on it saying, I've created a pointer that points at the address of I. That means I've now got a pointer aiming at this I. Hang on a second. So, here's my memory. This is going to be a little bit messier than normal because I'm drawing with a mouse. I don't actually have my stylus laptop with me, but should be okay. So I've created a variable here, and this thing is called I, and it happens to have the value 100 stored in it. Then I create the pointer, and let's say it gets put over here somewhere, and this thing is IP. So IP, when it gets created, where are we? This one? Oh, no. We're going to my Vlab here. IP, when it gets created, gets given the address of I, which means it immediately aims at I. So the connection between these two is that whatever address is in here, so it's 0x, I don't know, 55. Yeah, this is me trying to draw with a mouse. It's horrible. Means that this thing is aimed at this location. So, there's a couple of people saying, yeah, I could program locally. Yeah, we'll see how it goes. The one thing I like to do, and I like to try to stay really consistent with this, is that I don't really want to program in a system that's not the system that we provide for you. So if I start coding on my computer, then it's like, it's the implication that you have to set up your computer the way mine is, which is not true. Like, the only thing that I say that you have to use is to make sure that your stuff does work on the university provided systems. Otherwise, it's kind of like everyone out there who uses a Mac, I'm like saying you have to go get a PC to code the way I do. So I prefer to keep everything in the same systems that you use, or that are actually available to you. Anyway, so I've created this IP pointer, and this IP pointer points at this variable. So the action of using the star or not. So if I look at IP itself, so IP is equal to, at the moment, whatever the value is in here, which at the moment is this 0x 55 kind of thing. So if I do that, then I'm saying this is what's the value of the pointer. And the pointer is a variable. It has a value. That value is a memory address. And I just put a 55 in there because I don't even know what address this is going to be. It's going to be a big number, and it's going to be something that we don't necessarily understand, other than we get to the idea and the understanding that it is an address. When I use the star, the star IP, so the star, when I use the star, it follows the pointer to what it's aimed at, and then it grabs the variable out of there. So the star IP is actually the value of the variable in the location that the pointer aims at. So you go to the location the pointer aims at, and you ask it what's there. So that's the difference between the star and the not star. So if you put the star in front of the pointer, when you're accessing it, you're never going to know anything about the address. It's already going to have followed the address somewhere, so you're not going to get any address information. But if you don't put the star, that's how you can get the address information if you want it. Alright, so that's the kind of recap of pointers that we're up to. Someone was asking about if we can install the DCC compiler on our machines. It's technically possible. I've not actually tried it. I've always just relied on Vlab in terms of actually getting DCC. If you are running a Linux machine, you can get access to Vlab quite easily. This is actually something that if you want to, you can ask people in CSESOC about this, because everyone in, like, well, not everyone, but a lot of people in the CSE Society are later on in their degrees, and they've set up different kinds of programming environments. So there'll be lots of different ways to do it, and it's a much bigger conversation that we've got time for right here and now. James is asking, what if you write and IP? So, for example, this variable IP is sitting somewhere in memory. So if I was to do something like and IP, that would be another memory address. So this would be equal to, I don't know, I'm just going to make something up, 0x98. I don't know. I'm just making that up because it's somewhere else in memory and it has its own address. So yes, we could make a pointer to a pointer. But as I said last time, gets really confusing. So just be really careful about that. It is possible, and it makes sense for certain applications, but we're not going to push into that level of difficulty in 1511. We're going to get you the basics first, and then we'll build up on that. Okay. So the jumbler is something we were working on last time. It was going to take some numbers, it was going to change their order around and print them back out. If we have a look at our code, we're splitting this up into functions, and I think we'd gotten to the point where we could read input and print the numbers, but we hadn't done any swapping yet. So let's go back to our code. And we're going to edit our Jumbler code. Just going to tab complete that. Okay, so here's where we were up to previously. So we had the read inputs function and we had the print nums function. So where we were up to last time was the ability to ask the user how many inputs they wanted to type in, and then scanf an exact number of times of those inputs and write those into our array here, our nums_i array. I just realized on instinct that I was speaking really loudly because I'm so used to trying to project, and the microphones in the lecture theatre don't pick up that much, and so it's like I'm just like basically yelling at a webcam that's that far away from me. I realize that you can probably hear me fine even if I don't do that. So here are our two functions. One reads inputs, and the other prints outputs. So this one's going to loop through however many times our user has said how many numbers they're going to type in, and this one here is going to print out the number of items that we say we want to out of an array. So the array's got a maximum size, but we're not necessarily using all of the array, we're using part of the array, because we're using only the exact number of things that were typed in. Let's just have a quick look at that running. I'll compile it again, although I very much doubt anything's changed since last time we were here. So I'm going to name it Jumbler again, the same thing I had last time. And I'm going to run it with the /. And it's going to say how many inputs, so I'm going to say, I don't know, I'm going to put 5 inputs in. And then I'm putting 5 inputs in. I'm going to let my thing catch up, press enter. This is really weird because I've done this kind of streaming before with Vlab and haven't had a problem. As in, I did it from here the other day and it wasn't a problem. Okay, so it's read in those 5 inputs and then it's printed them out. So 1, 2, 3, 4, 5. So the only thing we haven't done is we haven't actually done any of the jumbling that we wanted the jumbler to actually do. And so what we're going to do is we're going to do this using functions. So the first function that we're going to do is we're going to make a function that can just swap 2 numbers. So the jumbler is going to shuffle things around, but it's not necessarily going to remove any numbers, nor is it going to alter any numbers. So anytime we do anything, we're just going to swap pairs of numbers around. So let's create a function called swap, and all it does is it takes 2 integer pointers. I don't have a good name for these. I might just call them A and B. Let me actually see what I did in the lecture slides. I called them number 1 and number 2. Yeah, the same level of the fact that I don't have a specific purpose for these makes it harder to name them. But num1 and num2 will be fine. So what I'm giving this function is the address of 2 variables. So if I have an array of variables, I'm going to make a new one of these. I won't bother saving that. So if I have an array of variables, and then I make 2 pointers, so here's a pointer, it's aimed at one of them. Here's another pointer, and it's aimed at the other one. If I give these 2 pointers to a function, they will know where this variable and this variable are, and they can do things to those variables. So knowing that giving a pointer to a function gives them access to individual parts of my array. So I'm not just, normally in a function, if I was to pass the elements of the array, it would copy out whatever numbers it saw there. So let's just fill these out. 1, 2, 3, 4, 5, 6. Normally, if I passed this element and this element to the function would have the values 2 and 4, and would be able to do things with the values 2 and 4. When I give pointers to these, it gives these actual access to these actual memory locations, which means I can make changes in the array. Usually, if I just give the 2 and 4, nothing happens to this array. Okay, so I'm giving pointers to 2 integers. I'll go down to the bottom of my code here and start adding that. So void swap, it's not going to have a semicolon, void swap, and it takes a pointer to 1 number and a pointer to another number there. When I make functions, I'm usually very careful to put a comment for every function I make, because functions are code that just sort of float around on their own, so it's hard to know what the context is of why we're writing this code or why this code exists without having a comment there to say what it is. So swaps the values stored in 2 integers. Just looking at the questions. Call them Bill and Bob. There was a question about, in the assignment, would we get marks deducted if there's a few variables that we can't really give a proper name to? If there's no proper name possible for the variables, then you're not really going to get marked down for it. If you've put a good effort into making most of your variables have a reasonable name, then it's okay. If we go into your code and we see like a whole bunch of A, B, C, D and stuff like that for variable names that actually meant something, like one was a mine location, one was part of a set of coordinates or something like that, then yeah, then we would mark down for that kind of thing. But if you've got loop counters called I, for example, like one right here, that's an accepted standard. We're going to use that, and that's fine. Um, if you have any trouble with that, you can always ping your tutor. So I've heard of this already happening, which is totally fine. People saying, look, I'm at this certain stage in the assignment, but I'm not sure how readable my code is, and they've emailed their tutor and said, can you do a quick code review of this? And then, yeah, the tutor's able to do that. They can read through and go, okay, these are the things that I would change if I was working on this. I think there's some ways to make this a little bit more readable. So totally okay to do that. Don't do that with other students, because then if someone else sees your code and they hand in the same code as you, then everything gets really messy, right? Okay, so swapping values stored into integers. So this is actually the code that I had up earlier. So in order to swap two things, I'm going to have a temporary value. So I'm just grabbing a little piece of memory so that I can chuck one number into that piece of memory so that I can swap things around. So if I've created this other little piece of memory, I can say, can I put the value of one of these in there? So I've just put the pointer in there, but what I wanted was the actual value that's sitting in that memory address. So I put the star there to say, follow this pointer to the value that it's aimed at, and then copy that value here into temp. So this moves the value of num1 into the temporary value. So then, because I've saved the value for num1, I can overwrite its memory without losing the value because I've saved it. So now I'm going to overwrite what was in num1. So I'm going to take that memory location and say I'm going to write over that with something else. So I'm going to take whatever the value in num2 was. Oops. Got to remember, using pointers, if you want the value that's at the end of the pointer, you've got to use the star to find the value, but by grabbing the address, following the address to its location, then finding whatever value was there. So now number 1 has been overwritten by number 2, so at the moment both of these variables are the same. They're both whatever value was originally in number 2. But I've saved the value from number 1 in this temp, so now I can say that the memory location at num2, so following the pointer all the way through to its value, I can now change its value to the one that I stored in temp. So what I'm doing here is I'm saying save number 1, then overwrite number 1 with number 2, then overwrite number 2 with what I saved in temp, which eventually means, so if I've got number 1 and number 2, then number 1 gets put to the side, number 2 overwrites number 1, then number 1 overwrites number 2, and then they're swapped. So it's just literally just swapping two values like that. Okay, so here's my simple function for swapping, and if I want to, I can just swap any pair of integers that's in this array. We could do a quick test of this if we want to before we print it out. I'm just assuming here that things are going to be okay with this, but if I want to, I can swap two of the variables in my array. So I'm just going to make sure that I actually put enough variables in the array to be able to do this. So if I want to pointer to a number, I can give it the address of a number if I want to. So I could say, and for the address of the first element in the array, and then the address of the second element of the array. So if I want to, I can do this. So I can say, swap the first and second. So let's have a quick look at this running and see how it works. I'm just going to go up through my commands to compile. And then I'll run this again. Okay, how many inputs? I'll do the same 5 inputs. Show you something interesting. I'm putting spaces between my inputs this time instead of enters. Scanf is still going to just go through and it's going to grab individual numbers out of this. And we see my output is now 21345. So we can see that the values for 1 and 2 have been swapped. So my jumbler is able to access the array, and it's able to change values around in the array. We've got a question there saying, why does num1 equal num2 overwrites num1 with num2? Instead, overwrite num2 with num1. So let's just have a quick look there. I'm not exactly sure what the question is there, but I think you're asking about which direction this is going in. So the equals is always an assignment. Assignment means we're going to give a value to a variable. So in this case, there's a variable at the end of num1, the pointer num1, and we're going to give that the value that was at the end of num2. So equals always goes in one direction. So there's always a left side and a right side. So we could think of the equals being something along the lines of, actually I'll just do this properly. So this is like num2. I'm going to draw an arrow. In a perfect world, I would love if we hadn't used equals, because equals mathematically makes you think that both sides are the same. Whereas in programming, the equals is not both sides are the same. The equals is more like this. Take this and put it into that. Actually, I'm going to put the pointer on there properly. So this is me saying this memory location that's at the end of this pointer, take this value and write it into there. So the best thing I would love if everyone thought of the equals as if it was an arrow aiming to the left. I mean, it isn't, because that's not the way we code, but if it was drawn like this instead of like this, I would actually be quite happy with that. Hopefully that answers your question there. Okay, so we've got one thing that can swap variables. And the next thing is we could have a function that runs that swap more times. So I've got a random one in here. I'm going to write something that may or may not even be the same as this. And this is a function that could be changed in lots of different ways and could be modified to do different things. And so long as it does some swaps between some of the numbers, we would be satisfied in a certain way with our main. So don't worry about too much about this code. Let's write something to call swap repeatedly. So I'm going to call it Jumble, and it's going to take in an array that is max num's size, but it's also going to know how much of that array we're using. So this is, I think we may have done this in the tutorials before, but this is us saying, here's an array and here's how much of it we're using, which may not be the same as max nums. So as you can see, we're making a 100 size array, but in all the examples I've been doing before, I've only been putting 5 numbers in it. And then every time we look at the length, that's us saying, okay, we're only going to use 5 of those numbers. Okay, so given the array and how much of it we're using, we have this jumble function. So I'm going to hop down to the bottom of my code here and say Jumble. I could have copy pasted that actually, but it's alright. I know what it was using. So the array in nums, then an int for the length. As before, I'm going to put a comment here saying what it does. Call swap repeatedly on different pairs of numbers in the array. Okay, any questions there? There's a bit of background noise. Apologies for that. I'm pretty sure, as someone else has noticed thing, is that, yeah, the fan is spinning up on my laptop. What I might do in the future, I'm not going to do it right now, although after we go on a break I might do that. is I can switch over to my headset, and the headset's got a much more localized microphone, which will only pick up my voice here and probably not the fans. So we'll see how we go. I apologize about the background noise. Everything at the moment with 1511 is just trying to improvise solutions to us not being able to be together physically. Okay, so if I'm going to do the jumbler here, we're going to go through and swap multiple pairs. So what I might do, I'm going to check the code I was doing there. Yeah, we'll loop through. Yeah, okay. That's a cool one. We can do that. So I'm going to have an I equals 0 and a while loop. So for the moment, I am assuming that the length is less than the maximum numbers, but what I should probably be doing here is saying I is less than length and I is less than max nums. Let me check if I did that before in my printout, while I is less than length. I'm going to say also while I is less than max nums, in case my user puts in a number higher than the 100. I mean, we really have bigger problems than that if the user does that, but oh, actually no, that's okay. So all of the loops that go through the array should either stop at the length or stop at the maximum size of the array, which is fine. I think this is a correct comment. I'm not sure. It depends on what I do with I. In fact, I have a feeling that's not going to be, because I'm doing weird stuff in this loop. Okay, so here's a loop that for the moment would go through the entire array. But what we're also going to do is, because we have two elements that we're going to swap, so we're going to look at one element in the array and one element somewhere else in the array. So what I'm going to do is make another integer, and the first thing I'm going to do is say this integer must be different from mine. And so I'm actually making this up as we go, because I'm just picking another integer somewhere in the array to swap with. So the way that I was doing this before is doubling the one that's there. So if it's 0, it's going to be the same. If it's 1, it's going to be 2. If it's 2, it's going to be 4. From your angle, it's going in that direction. Sorry, I got to remember to reverse the way I'm thinking when I'm showing stuff physically. So this is just picking another location in the array. So I'm just picking another array element, and then if that's actually part of the array, so if there's actually like a legal element in the array, so if j is less than length and j is less than max nums, j is an array element. So if I made it into this if statement, then j was an array element. So if that's the case, I know I is an array element because I is just looping through the array. And so if j is also an array element, I'm going to allow them to swap. So I know that both of those are array elements, and now I can call my swap function. And I can say the swap function is taking two integer pointers. So it's taking the addresses of two integers. So the address of one integer is the address of nums at index I, and the other one is the address of nums at index j. So what this is going to do is it's going to loop through the array, try to find the j, which is somewhere in there. So this is only going to work for some of the i's. Once we get past halfway through the list, the doubles are going to be too big. But at least it's going to find some of them, and it's going to swap them. I'm going to put a note up here. Put it down the next line. I'm going to say this function could be written in many different ways because it's not necessarily something that has to be like this. This is just me grabbing random things out of the array and then swapping them. Yathan Surish is asking, why do we make it less than max num? So, oh, thank you. Cooper is already answering this. We want to make sure that we never try to access something that's outside of the memory that we've claimed. So, in the beginning, this is the memory that we're playing around with for the array. It's an array of max num size, and max nums happens to be 100. So it doesn't really matter what that is. We could change that to different things. But what we're checking for is we did ask the person for how many numbers they were going to input. If they were to give us something that was equal to 100 or over 100, then this max nums becomes important because their number might have been higher than 100, but we still only had 100 integers worth of space, so we never want to go over that. So this is us saying most of the time we're going to stop at whatever length they gave us. But if they've given us a number that's too high, we want to make sure that we don't go over the amount of memory that we have, because we don't want to access memory outside of the array that we've declared. Yeah, so Yathans, the only issue is that if we if length is higher than max nums, that's the only issue that we might have. Someone's confused about the j times 2, and also why are we swapping the addresses instead of the values? Okay, so the j equals I times 2 is literally random. It's actually not random at all. Sorry, that's me just going pick another element. So we could do something like this. I plus 1, that would also be picking another element in the array, so that would be taking all the pairs next to each other and swapping them. We could have it I plus 1000 mod length. That would also be an interesting way of just trying to pick another element in the list. So the multiplies by 2 was just pick another element, and this was the part of it that I was saying this function could be written in many different ways. I'm going to try this one actually. This one seems interesting. I times 1001 mod length. So the mod length is going to push it back into the bounds of the array, but the 1001 is going to just mean it's somewhere. Okay, and the other question was, why are we swapping the addresses of these? Because swap here, look at the input of swap. The input of swap wants pointers. And you're going to remember what a pointer is? A pointer is a variable that stores a memory address. So if I give it the address of this variable and the address of this variable, they're going to take those as valid inputs for those pointers. And the reason why we're sending pointers in, so if I had a valid swap function that could take numbers, then it would make no changes to the array. Because if I gave it this, all it would get is a copy of the number that was stored in I and a copy of the number that was stored in J, but it would not get access to the actual memory locations that I and J are in. So it wouldn't make any changes to the array. If I say this, it's very different because I'm telling you where these variables are so that you can make changes to them. Okay, let's save that and continue. That work? Uh-oh. There we go. I'm pretty sure I'm spending all my bandwidth on streaming. Having said that, I've done this before, so it might be that I've never done it at 10 a.m. and I've never tried to do it when that big chunk of Australia is on lockdown and now we're all sharing the internet at the same time and everyone's working from home at 10 a.m. Alright, from here on we're moving all the lectures to 4 a.m. when no one else is using the internet. Let's make sure I don't have anything open in the background. Let's close that. Close that. I don't think any of those other things are going to take up any bandwidth. I may have to figure out another solution to this. This has been quite reliable. I mean, if you've seen any of my other live streams in the past, I was able to do this on this same internet connection without any problems. Okay. Thanks, Cooper. I saw that icon as well. I will get to that eventually. Probably not right now, though. Okay. So I'm going to compile this again now that I've made changes. Hopefully this compilation works. And I'm going to run my Jumbler. Okay, now we're going to say how many inputs. I'm going to do the same set of inputs so that you can just see how this is working. So if I give it 5 inputs with 1, 2, 3, 4, 5, hopefully I'm going to get a mess of numbers that are no longer in order. Okay, 1, 2, 3, 4, 5. Ah, 2, 1, 3, 4, 5. Does anyone want to point out, because I've just realized the mistake I made. Would anyone like to point out why this has only swapped the first 2 numbers? It's a crucial part of how we use functions that I may have missed by accident here. I'll give it a second because the stream is a tiny bit delayed. I think it's like maybe a few seconds behind what I've been saying. Calvin's idea is that I didn't print out. I did though, because I definitely printed out this next line here. Or maybe you thinking, did I save? Wait, there we go. Sunny and Simply Me both figured out I didn't actually call that function. So I made a function, I didn't call it. Let's go back to my code. So I wrote this nice function here called Jumble. Jumble was going to do this multiple swapping thing. It was going to go through and swap in many different places. And then I can come back here to my main and I can have a look at what I'm doing here. Jumble's never been called. Oops, I went too far. So Jumble's never been called in my main here, which means I'm missing something. But I still just had that first swap that I put in there as a test. So that's why I was getting that output, is because I wrote this nice function and then I never used it. So let's use this nice function. I'm going to replace this little test that I put in there. What are other people saying for the function? J++ is missing, someone is saying, and someone else is saying, I don't need the J++. Yeah. So Syed Hamza there has the answer that if I was looping within a loop and I wanted the J to change on its own, then yes. But I was setting J differently each time. So J wasn't actually going through all possible elements. It wasn't looping a second time. If you note, there's only one loop in Jumble. Where is it? That should work. There's only one loop in Jumble. So the J is just dependent on the I. As the I changes, the J then changes to something else. But note, there's only one while loop. So we're not using J as a second counter. If I wanted to, I could actually call J something else. I could say other, even just other. So I'm not saying it's a looping variable. So it's actually pretty bad style on my behalf to call that j, because j is something that we would consider, like I is something that iterates through the loop, and j is something that iterates through another loop. So if I call it other instead, um, that gives us the implication that it's not a looping variable. It's another um, number, and I think that's a better way to name it. So actually, thank you for talking about that, because that just shows me that what I wrote wasn't very human readable. Because if it could throw people off, that means it's not something that's obvious about its use. So J was a bad name for that. Making sure I've changed all the places where J was being used. Yeah, I think that's okay. Alright, so let's go back up to our main. So the point where I wasn't calling it properly. I have a feeling we're not going to get to characters today. I spent more time on this than I was planning on. But I think it's good. Sometimes it's really good to write some code and get really deep into it. Now that we're in this kind of awkward, loose state of the world of COMP1511, the boundary between me doing live streams and video content and lectures is not the same as it was before. It used to be that lectures are this big official thing, and all the other content is somewhere else. But now we're in a world where if I want to, I could just put up a whole bunch of short videos and teach you through that. So I'm not necessarily going to do that. I'm going to try to keep it reasonably similar to the way that we were teaching it before, but I will probably be throwing up some videos about other things. I'm not sure if did I actually do that? My Vlab is struggling. Probably gonna go and just like restart my router when we go on break. Actually, no, I can't do that. That would kill the stream. But I am most certainly not getting a response out of my Vlab, and okay, I'm going to restart this. Lovely. Okay, you know what I'm going to do? Because let's see if that slowly comes up. Because I am getting too much lag here to be able to do this. I think, yeah, this is actually really weird because this is never this slow when I'm streaming normally. But anyway, what was going to happen then with the function put in place there is it was actually going to jumble things, like assuming that it was compiling correctly and stuff like that. And any errors we need to fix, we fixed. That would have been fine. What I might do now is take a 5-minute break and see what I can do about my internet connection. Alright, so what are we now? About 10 past 10, so we'll come back in about 5 minutes. If anyone has any questions, feel free to chuck them in the live chat. I'm going to step outside for a bit and just see if there's anything else in my house using my internet at the moment. Alright, I'll be back soon. Okay, we're back. And Vlab's not liking me there very much right now. The good thing is, a lot of what I was going to talk about today was not necessarily code, but approaching code in certain ways. So, we're just gonna let that go for now. I'm gonna put that in the background and let that happen. Okay, so one of the things that was nice about this was that our main function looks like this. So in the end, our main function is just very, very small amount of code with some English language stuff that we can read reasonably easily. These aren't exactly the same names that I used for things in my code, but they are pretty much the same functions. So we set up an array, we said read the arguments, jumble them, and then print them out. So there's a whole bunch of while loops and all this stuff happening there, but you don't actually have to see it if you read the main. So the main ends up being this lovely kind of I can just read this and just go, oh yeah, there would be a whole paragraph of code doing this here, then there would be a whole paragraph here, but instead, I've just got the word jumble and I've got the words print nums here, and it's really, really easy to read your code then, because you just go, this happens, and this happens, and this happens, and this happens, voila, that's it. And there's like hundreds of lines of code back there making all this stuff happen, but you don't have to think about it, which means someone can read this and have a full understanding of how it works. And then they go into the details if they want to, look at the functions. Okay, so a couple of things that we did with this. Separated everything with functions, and also we used pointers to give us access to the memory to be able to swap it. So the next thing that we're going to look at today, so I was hoping that example would be a lot quicker than that, but in the end I spent ages on it. But it's okay, I think it's useful. So we're going to look at debugging today, and I realized that I am showing my age by putting in movie quotes from things that people may not have seen. But I don't know, maybe some people have seen Aliens. Look, in terms of other things that were made in the 80s and you can watch now, this one aged pretty well. So, still a movie worth watching if you want to see the movie Aliens. It's like a action thriller movie. And one of they have to fight these bugs, and one of the things they say is, say we take off and nuke the entire site from orbit, it's the only way to be sure. So that would be akin to us just deleting our entire code project if we can't figure out what the problems are. But what we want to talk about today is how do we remove bugs from our code? So bugs are it's a programming term that we call issues that are in our code, or issues in the way we were thinking about the code when we wrote it that cause it to not function the way that we want to. So a bug is anything that stops our code from running the way that it should or the way that we intended, and debugging is a term for how we find those problems and how we solve them. So your question is, what is a software bug? So any error in our code we can call a software bug, but sometimes those are obvious. So sometimes those are like language errors. We call them syntax errors sometimes. So it's just us typing in something that's not C. The easy thing about syntax errors is our compiler is going to give us a lot of suggestions about syntax errors. But the other one, which is much more insidious and much harder to find, are what we would call logical errors. And logical errors are, we have typed in perfect C. You know, it's perfect language C. I think I was talking about this last week. So I could say a phrase like, my internet is working perfectly and there are no problems with Vlab in the stream. And that's a sentence you can understand, but you can tell me, no, Mark, that is wrong. In which we can see that it's wrong. And so that is nearly what we would consider a logical error. Your compiler is not going to notice it. Your compiler is going to say, hey, no, that's cool, all this is working. I can compile this, I can turn it into a program, you can run the program. Then the program doesn't do what you wanted it to do. So those are logical errors. They tend to be harder to find, but we're going to go through a couple of techniques for how we're going to remove both syntax errors and logical errors from programs we've written. I'm sure people are getting this more and more now because we're starting to work with a larger project. in the assignment. And the way that we chain together parts of the assignment is you do stage 1 first, then you use stage 1 in stages 2, 3, and 4. You do stages 1 and 2, you use both of those stages in stages 3 and 4, that kind of thing. So if there are problems with your earlier code, they may manifest later in your other code, and it makes it a little bit harder to solve these problems. But again, this also makes it much more realistic because real programs are much bigger than the lab exercises we've been doing. So we're building you up into problem solving in larger things. But obviously not just throwing you in the deep end. I'm going to show you some ways around it here. So syntax error is what we could think of as a specific language error. So C is super specific. I think I said this very early on in the lectures when I said, does anyone ever have those, like an English teacher who would like basically refuse to talk to you if you weren't speaking with perfect grammar? This is that kind of situation where your compiler will only understand you if you've written perfectly formed C. I mean, you've noticed this already, right? Anything like leaving off a semicolon or brackets in the wrong place, wrong number of brackets, the compiler is not going to be okay with any of that. So most syntax errors are really obvious. Like your compiler just goes, there's an error on this line, and you look at that line and you go, yep, there is indeed an error on that line. I have swapped something that I was supposed to, like, or I've just left off a semicolon. That's like one of the easiest syntax errors for your compiler to find and tell you exactly where it is. Some of them are harder to find. So a lot of syntax errors, your compiler will tell you the consequence of the error, but not necessarily what line caused the error. So the easiest example of this is forgetting to close brackets somewhere. Sometimes you won't get the error for the forgetting to close brackets until the very last bracket of the program. Because sometimes magically, if you leave off a closing bracket, all the rest of the code was still legal all the way through to the end. If you would just shift some things inside each other, it would still run. But at the very end, it goes, well, I needed one more closing bracket. Something's still open here. And so sometimes you won't see the actual error. You'll just see the consequence of the error coming up somewhere else. Logical errors, as I said before, these are when the program is working, and by working I mean you can compile it and run it, but it's not doing what you expected it to do. So this is the sort of human error side of this. So remember when we were talking about pair programming, I was talking about having two people on the computer. One person is doing the syntax. So one person is saying, okay, make sure we're typing in proper C, make sure we're building structures like if and while loops. The other person looking over the shoulder is like, hey, can we make sure we're solving the problem? This is what I think we should do. I think we're going to need an algorithm that does this. An algorithm is like a recipe, in a sense. Like an algorithm is like saying, okay, do this, then do this, then do this, and together they're going to form a solution to our problem. We as humans can make mistakes in both places. But the logical errors are very, very human errors. So that's us saying, are we actually solving the problem we're supposed to? So for example, if I gave you a really vague idea about what Minesweeper was, and then you went through and just started coding Minesweeper without ever looking at the assignment spec, the chances of you actually completing the assignment spec are very, very low. Right? So sometimes we don't read the question correctly when we're answering it. And this is something that goes all the way through into the computing industry, where we create entire programs that never actually had any need. So we create an entire program that no one ever actually wanted. I'm trying to think of a good example of this. I'm not even sure, because basically anything that we're going to hear about is usually going to be something that actually had a human need at some point. Oh, did anyone ever use Google Wave? I actually liked Google Wave. I thought that was a cool tool, but I think it was something that was ahead of its time, and no businesses actually needed it at that point in time. So Google ended up scrapping the project. So we get that kind of thing in industry, where sometimes we don't know exactly why we're creating something and we forget, and then we just go off and create it, and it doesn't necessarily meet the goals or the needs that we were supposed to be making for the program. So sometimes we do that. Sometimes we get halfway through our code and we go, oh, that's really interesting. We go off on a tangent and we make something interesting and we forget what the program is for. So this would be very similar if you're looking at lab exercises of the assignment. It's just forgetting which stage of the program you're on, what it was exactly you're doing, and then you do perfect code. It's beautiful, it works really well, and it just doesn't answer the question because it's off on another tangent. So those are the kinds of things that happen to logical errors. Or sometimes it's just like, I intended my code to do this. I had a full intention for it to do something, and then as I typed it in, I typed in correct code that just didn't do the right thing. So let's say I looped the wrong number of times, or I looped inside a loop, but the one inside wasn't necessary, other things like that. So it's pretty easy to get confused as a human and do things that are slightly incorrect. So what we want to do is we want to have a solid process for finding what these bugs are, how to catch them, and then how to correct for them. So first and easiest thing, and this is something that I think everyone's probably been doing already, is how to use a compiler to catch bugs. And so one of the easiest ways that we've seen to use a compiler is simply run DCC and then see what it tells you about your program. So we can catch a lot of syntax errors like that. A lot of syntax bugs are going to get caught just by running your compiler. A lot of the activities that we've been doing in the course will help people to find logical errors. So code reviews are great. So when you do a code review with someone and you say, hey, this code's for doing this, and they look at it and they go, okay, that's different from how I would have done that. How is it working and stuff? And you have this conversation about, yeah, so we loop through here and then we loop through here and it does this. And you're like, I'm not sure if we needed all of that to do that. Are you sure that's actually answering the question? And then you will have that conversation, and then you may find out that you've made a logical error in how you're doing things. The other thing that we can do, this catches both kinds of errors, is testing. And learning how to test is important, because testing often involves writing code that is of no value to you in terms of the finished product. So it's code that has nothing to do with, say, printing the correct output for Minesweeper, but instead what this code does for you is it tells you what your program is doing as you're doing it. And if you can see into the inner workings of your program, it's easier to see which bits are working and which bits aren't. So, simplest thing, running the compiler to get syntax errors, finding out those bugs, is run DCC, see what happens. If DCC compiles, so if it says nothing, then you don't have any syntax errors in your code. Or you don't have any easily detectable syntax errors. You may have other issues in there. So I think we could write code that would address outside an array, which we could consider to be a syntax error. I mean, could be considered a logical error. But DCC would let you run that. And then when you run it, you might break. So sometimes we can get errors later on. And so that's when we call errors in runtime, so when the program's running. But most of the things we're going to use the compiler to find are compile time errors. So compile time, as in we run the compiler and it says to us, I couldn't compile for the following reasons. So everyone's seen this, right? You run DCC and you get a bajillion errors and warnings. When you get that, always start with the first one. So scroll back up to the actual command that you typed in when you typed in DCC and look at the first error. Because a lot of the time there's one error at the top that causes a chain of other errors. And there's no point looking at something halfway through the chain or at the end of the chain. You always want to go back to the start of the chain. So sometimes when I'm debugging, I will compile, look at all the errors in my compilation, and go to the very first one. I'll just go to the very first one, solve that, and ignore the rest of them. You know, it can be daunting when you've got 30, 40 errors, or even more. But if you just look at the first one and fix it, then you know you've definitely fixed the first thing that caused a problem, and then I just compile again. So I don't even look at the others. Sometimes I'll just look at that first one, fix it, compile again, look at what is now the number one, public enemy number one that's there at the beginning, and then see that. Because sometimes after fixing that first one, it just changes the entire environment of errors that are happening. So the other things to think of is the compiler is not smart enough to tell you exactly what you've done wrong. So it's going to Oh, I just realized that I'm blocking some of the letters. Oh, there you can see it better now. My face isn't blocking as much. So say it's asking if runtime errors like division by zero are logical errors. Yeah, you could think of that as a logical error because it's you asking the program to do something that may have been correct most of the time, but then you allowed a zero to get into the division. Or you allowed your program to go outside the bounds of an array, and so you've caused some problems there. So some of those things you could consider to be logical errors because you haven't written the C incorrectly, but you've used it incorrectly later. The difference between what is a logical and what is a syntax error is not something that I think is super important for you to definitely know, but we sort of treat them differently in how we try to solve them. Okay, so when we have compiler errors, so I've gotten us to the point where we're going to look at our compiler errors and we're only going to look at the first one. So if we're looking at the first one, we want to unpack that error and see how we're going to fix it. So the compiler errors and compiler warnings. So compiler warnings versus errors. So these are the two different things a compiler is going to give you. The warning says, I could compile this and you could run this, but I think there's a problem. I would never ignore warnings. I'm very, very careful with these warnings because usually they mean something like what Syed was saying there, is that you've got the risk of going off the end of an array, or you've got the risk of dividing by zero or something like that. And the warning is saying, are you sure? Because you're doing something that people don't usually do. So I would be careful with this. So I usually fix warnings like they're errors because they're potentially dangerous and they're kind of insidious because you can still compile the code with warnings, but it means that somewhere later on you might have a problem and it's much harder to find it once it's deep in your system. So anyway, let's look at the first warning or error and we say, okay, look for the line number. That's always going to narrow down what we're doing. If we see the line number, then we might be able to see what's going on. Sometimes just going into your code at the location that the warning was is enough, because you can just go, I see my problem already. Thank you for narrowing that down. I wouldn't have seen that if I was scanning 100 lines of code, but when I'm looking at one line of code, I can see it. The next thing is to look at the error message and see if you can figure out what it means. Not simple. A lot of error messages are super weird. A lot of error messages are not telling you what's wrong. They're telling you what fell over after something else was wrong. So it's kind of like if you got this isn't a real error message, but you get an error message that says that building fell over, and you go, yes, I can see that building has fallen over, and then you just go, there's a giant semi-trailer crashed into the building, and you go, oh, that's why that building fell over. But the compiler doesn't know that much. It's just going to tell you what happened, not what caused it to happen. So sometimes you need to step back through your code and figure out how that problem could have happened. But they will try to tell you things. The compiler will try to tell you things like, okay, there's something missing that I should have been there, or I'm super confused because you've done something incorrect. You've written something in a way that didn't make sense. Alright, so there's a break here. So this is how far behind time I'm running today. This is where I expected the break to be. So I'm just going to leave this slide up for a second so you can see it. It's pretty funny. There's an entire field within computer science of people who test code. So people who make it their specialization to break your code. So they will come in and well, I mean, it's like super helpful actually, because it's much more embarrassing if no one tests your code and you try to publish it and everything breaks. Anyone ever play Mass Effect Andromeda? Anyway, this is really for the gamers out there. You'll know this. This was only like in the last couple of years. It was a game that was definitely released before it was finished. So there were really, really funny, obvious graphical errors in this when it was released, and things that weren't that hard to fix. But they just needed another couple of months, so they didn't have these QA engineers coming through and making sure things were working. But this is hilarious what happens, right? See, when we go in and do our testing, we test all these different values, and then something else happens, and the first time we do it for real, something goes wrong. Alright, there's some talk in the chat, let me see. There's a really good question in there from Calvin saying, can we write another testing program to test our programs? Yes, we can, and a lot of the time we do. In fact, the second assignment will have some stuff like that in it, where we will have our main that runs our program, but we will actually be able to compile a different main function that instead of running the program the way it would for a user, it runs the program in an automated testing cycle. And that way what it does is it just pings all of the functions you're supposed to create and sees if they work or not. So it's like running auto test. For example, the question of, can we write another testing program to test our programs? Yes, we can, and we have already called 1511 auto test. So that's another program that we run that basically takes your code and says, all right, I'm going to throw a barrage of inputs at it, and I'm always expecting certain outputs when I put those inputs in, and then that will test which things are and aren't working in the code. When we're talking from an industrial perspective, we do that a lot. Milkshake Gamer, that's a very nice way to think about it. Runtime errors are usually caused by logic errors, but not all logic errors cause a runtime error. So they may not cause your program to crash when it's running or anything like that. What they might do instead is simply cause your program to answer incorrectly, but it will answer, it will run, it will complete its running, and it will be happy that it's completed everything. But it still might be incorrect. Like, you can be giving an incorrect response, but executing correct code in a sense. So it's running, it's finishing, it's returning 0 at the end, all this kind of stuff. Yeah. And there's a question there about assert. We're going to go into that later. Yes, we will be using asserts. Asserts are ways we can get our program to sort of test itself as it's running. I don't want to go too much into it because I'm actually going to teach you about it later. So yeah, I like that a lot of people are already thinking about problem solving, not problem solving, like error correction and stuff like that, which is really good. Okay. So here's another little meme, which is pretty funny because this is something that definitely happens with our code. Is we've got some bugs, we patch a bug to fix it, and then more bugs appear because the thing that was setting off a chain of errors moves to somewhere else, and then we have more problems. So I wonder if we're going to be able to do this. Okay. It's awkward that this is really easy. Actually, even this is loading a bit slower than normal. I have a feeling that... So, I don't know if you can tell. You can't really tell from where I am. I do live in an apartment block, and I have a feeling that my entire apartment block is working from home today. And so, even though I'm on NBN, yeah, everything's coming in really slow. So, best I can do... Oh no, I don't want to view that directly in browser like that. I'm going to have to set up some way of coding just locally on this machine, which I never have because this is my home machine. I didn't actually get my work machine and bring it home because I didn't realize that on Friday that things were going to go quite as pear-shaped as this. Maybe I'll risk going into UNSW to pick up my machine, but we've already had a few cases of coronavirus there, so I'm not sure if I definitely want to go back at all for the next couple of weeks. Yeah, everything's a little bit slow. Oh wow, this is just loading up the page and it's slow. Okay. So, this is the code that we were going to debug. So I would have put this into a compiler and and had a look at some of the problems. I'll leave that for you to do if you want to. So grab this code. Who knows what speed Vlab is going to work for you at this point, but you can grab this code and have a look at what happens when you compile. So there's a few errors that you're going to find initially when you do the compilation. I'll actually go through some slides about it now. But it's an interesting one because this is supposed to just print out grids of stars. So it's not even using arrays or anything like that. It's just looping a double loop, printing out grids of stars. I think we did this in one of the lectures as well. So it has some problems in it, and if you compile, you'll find some compilation errors. As you get closer, you'll see some issues of how things are going wrong, and there's some logical errors in this as well. So it's going to be interesting to do some debugging in it. So some spoilers. I'll talk through some of the spoilers because I think it's worth looking at as well. But what I might also do is, once I've figured out my internet or set up a local, let's see if that logged in. It started logging in. Still very slow. No, I'm not going to bother. It's just going to waste our time. I might do this later, or I might do this in a video and show it to you. So I'm going to skip some of these slides, and we're going to go through this in a separate video. So this has got a lot of information about some of the stuff that we found in there, some of the stuff that caused errors, and I do want to go through and show you the testing and show you how I would set up testing in that kind of environment. So bear with me. I will either have this set up to show you tomorrow, or I will do a separate video that just shows you exactly how we would debug that program, but not just debug that program, but how we would actually run testing to do this kind of needle in the haystack thing, find out where our logical error is and stuff like that. So we'll go through that, but I've got a few minutes left, so I wanted to talk about the other topic that I wanted to start bringing up this week. We are going to get deeper into this tomorrow as well. So we're starting with characters, and tomorrow we're going to expand this to words. So at the beginning, it's just going to be single letters. Well, for like less than 24 hours, it'll be single letters. And then we're going to go on to what's called strings, which is multiple letters together. So I apologize about the debugging and testing thing. I will find a solution to that though, and I'll make sure there's material out there for you to learn from. Anyway, on to characters. So, up until this point, the only variables we've been using were ints and doubles. So, that means that we only had numbers, but we know that we as humans definitely communicate with letters and words and stuff like that. And so we're going to bring those in, and we're going to be adding those to our code that we're learning from here on. So we're able to now give things names, for example. So we could put a string on something and say, okay, this is a word that's attached to this, and we're going to treat them similarly to other variables. So this is our new variable type. It's called char. It's not a Charizard. It's a character, and these are just individual letters, A, B, C, but they're also any character. So this is like any character that I could type on my keyboard here. So all the numbers are also characters, which can get confusing because you can't really use characters as their numerical value without some kind of work converting them. A character is 8 bits of memory, so a character is actually much smaller than the integers we're using. And the other interesting thing about them is they're actually stored in C as integers, because everything in C is based on the zeros and ones, the bits. But the characters are really interesting because they're literally encoded as integers. So when we have a character, it's nearly an 8-bit integer. There's obviously a Pokemon fan in there. Yeah, so this means that when we're using a character, there are things that we can do with it the same things that we could do with integers. So we can do weird things like add characters together. They will actually give you a result and things like that. But the way that they're encoded is this encoding called ASCII. ASCII, which originally was the American Standard Code for Information Interchange. I have to look that up. I don't bother memorizing it because it's not important. Um, so the meaning of that is whenever I press a key on my keyboard, if I have an old keyboard that plugs into my computer, or even just like nowadays you plug a USB keyboard into your computer, that kind of thing, um, when you press each letter on that keyboard, it actually sends that number to your computer. And it's that ASCII number that represents the key that was pressed. The original characters were just the keys on the keyboard. Nowadays we've got way more of them that we can use for other things. But in general, it's just things that you can see in your keyboard can be encoded as characters. One of the interesting things about the char variable type is we're actually not even going to use it that much. We're only going to be using the char variable type when we're using it for strings, so for arrays of characters, which is what we'll talk about that tomorrow. When we're using individual characters, we actually were often going to be using them as integers instead, and I'll show you why in a second. So ASCII specifically uses the numbers 0 to 127. So it's only half of the 8 bits, except the other 8 bits will be used for other things to do other characters. But traditionally, the standard ASCII was just 0 to 127. You can actually look up the ASCII table. So I've just picked up a random one here. Oh god. If you can see that, doesn't matter. I actually don't care. I don't really use the ASCII table that much, but here are 8 bits and their ons and offs, and in this column here you can actually see letters, capital letters, lowercase letters, numbers, stuff like device control, shift and space and other stuff like that are in there. So pretty much anything that we could hit on our keyboard can be sent through as an ASCII code. So these are all the things that have ASCII values: upper and lower case, digits, punctuation symbols, space, new line, other stuff like that. I want to say that there's absolutely no need to memorize ASCII. There's no need to know what the values are for each of the letters or anything like that. We're never really going to be using them for their specific values. We may do some maths on some of the characters, but we're not going to need to memorize it. So don't bother memorizing it. We have an ASCII table available for you in the weekly tests and the exam and stuff like that, but you can actually get away with never looking at it, and you'll still be able to solve all of the problems that we have in 1511. So the way that we might use characters in code. So this is really interesting, right? Because I've said int for character. So just make sure you can see all that. Yeah, I've said int for character, which is very, very interesting because that's quite different from what I just said, where we have a new we have a new variable type called character. I'll show you in a moment why we would use an int. But what we can do is this now. So what I'm introducing to you is this value here. So remember when we just typed a number into our code, that was just the value of the number, but not necessarily a variable of it. But I can have a value a, and a, if I assign that to an integer, it will store the ASCII value of a into that integer. So if I were to use that integer as if it was a character, it would come up with the letter A. If I use it as if it's a number, it'll come up with the ASCII code for the letter A, which I think is 97? I've memorized only some of them, like A and stuff like, or it could be 90, 96. I don't know, doesn't matter. If I wanted to, I could run the code to find that out. So now there's a few new things we have. Single quotes around a letter are going to allow us to say, please represent this letter. So this is an actual value that I'm putting in, and I can put it into variables, so I can store this as a character. And the other thing we have is a printf flag, and this can be used for scanf as well, but there's other things we can use for scanf. And this %c here says read a variable as if it was a character. So we can actually read any integer as if it was a character. Some of them are going to have visible characters, others aren't. If you're within the values of 0 to 127, you've got more of a chance of it being a visible character. So you could actually, we could just have that integer I of 100 that we were using before and print that out with %c and see what letter that actually was. So we can see what its ASCII value is if we see both of these are the same variable. So if we treat it like a number, we'd see the ASCII value. If we treat it like a letter, we would see the letter A here. A couple of questions there. Someone knows. Small is 97. I thought it might be 97. And a lot of discussion about Pokemon. Yep, so a lot of people have worked a little bit with characters here before, and so there's some information there in the chat if you want to have a look. But I should also say that we'll 100% get away with not knowing that. Because if I ever want to know where the letters start, I can say, look, just give me a number for A, and I know that's where the letters started. And so if someone were to change the ASCII encoding system on the computer I was using, I don't know if anyone would ever do that, but if they did, if I just used the character A and things like that, I would still be able to assign a value to it. So there are some really useful functions we can use. And so now that we know that the standard input-output library, so hash include standard io.h, that line that we put in there wasn't just giving us printf and scanf. It was actually getting us a whole lot of other functions. And now that we're using characters, we can actually use these functions to kind of smooth over the way we're programming. So we're using code someone else has written, we're using code we trust because thousands and thousands of people around the world have been using it for years, and so we're pretty sure all the errors have been removed from this code. We can do something like getChar. So getChar reads a byte from standard input. Remember, a byte is 8 bits. And I also said earlier that a character was 8 bits. So when I say that getChar reads a byte from standard input, what I'm saying is that it's reading 1 character's worth of information from standard input. And when I say standard input, I mean usually this is just my user typing stuff into my program. The way that we've been doing this up until now is using scanf. But if we want to, we can do getChar, and instead of scanf was, processing things as if they're numbers, or processing something as if it's an integer or as if it's a double. getChar doesn't do that. It just says 1 character at a time. So what it's going to do is I'm going to type in a whole bunch of characters, and if I loop getChar, it's going to take those characters one at a time, and then it's going to tell me an integer for what the ASCII code is of that byte that it read. And here's the kicker. This is why we use integer instead of characters, is sometimes getChar will return a -1. So if getChar returns a -1, that will say end of input, which says that I read to the end and someone pressed Control D, or this is not something we're doing in 1511, but you'll see this definitely in the future. I read to the end of the file you are asking me to read, and there's no more information here, so EOF actually stands for end of file. getChar will say there's nothing left, and if it says there's nothing left, it'll give you a -1, and then you can say you can loop until you get that -1, and then you stop. The interesting thing about this char variable is the char variable cannot store negative numbers. It is literally 0 to 254, I think. Yeah, it's 8 bits. 0 to 254. So because it can't store the -1, if we used getChar and used the char variable type, we wouldn't be able to see whether a -1 was coming out. Which is why when we're doing individual characters, we'll always do them with an integer, just in case we need to catch this -1 from getChar and say, oh, our input is finished. The other thing we might get is if we're looping getChar multiple times, sometimes the stuff that my user types in doesn't go directly to getChar until they've pressed enter, and then the whole line gets passed into my program. That's a little subtlety that we'll get into. Putchar is really similar to getChar, and it looks like it's nearly like, putchar with a character in it is nearly exactly the same as printf character this. So putchar is just a simplification of this printf statement. getChar is a little bit more complicated because it's reading them one at a time and can signify with a -1, that kind of thing. Questions about Unicode and stuff like that. I'm going to let you just have that conversation there. There's deeper things that we can look into, and I think it's quite interesting that we actually now have this live chat where people can talk to each other about stuff like that. But that's a bit more advanced than what I'm going to say here, so I won't bother looking at that just yet. So, if we want to look at some code that uses getChar and putChar, as I said before, if I'm using an individual character, I'm going to use it as an integer just in case getChar gives me that negative value. So I don't want to have this as a char for the moment, but I can still display it as if it's a character. So this bit of code here asks my user to input a character, and it will call getChar to see what that character was. It'll put that in the input character variable, and then we will be able to print out, okay, this is the character here, and so what you will get hopefully is the same character that you typed in, and also what ASCII value it has, and then it will write it back out. So if we were to run this code, when I have my setup going again that's running code, we will be able to see that we can see the ASCII value, but also the character. One of the interesting things about this is the invisible characters. There's actually plenty of characters that we have that won't actually appear on our output, but have some effect either way. So the new line is one of those characters. I mean, it still has an effect, but it doesn't have a visible character that you can see. What it does, it will move the cursor down to the next line. It has its own ASCII code. So new line has an ASCII code. Space also has an ASCII code. So all of these have numbers that represent them. They can be stored as a character, that kind of thing. And each of these can be read in and also printed out. So if I do a putChar for a space, it'll just shift my cursor along, so the next thing I type will be spaced from other things. So when I'm talking about char as a variable type, when I'm talking about using letters and things like that, I'm not just saying the letters A, B, C, all the way through to Z. I'm saying we've now got all these characters that we can do other things with. The EOF is a very special one that signifies there's no more input. It does actually have a value, and it's hash defined in the standard input output library, so that we can use capital letters EOF, and we can use that as a value when we're testing against things with testing for characters and stuff like that. And we've seen this already because we put this in the tutorials and labs last week. I think it was last week. Yeah, week 4, so that you would know how to do this for the assignment, because we were using Control D in the assignment. So Control D is very often used with something like getChar, where you type in a series of characters, or you've got a stream of characters coming in. These can, when you get more advanced into this, be coming over a network connection, or they can be read from a file from your hard drive, and at some point it ends. And so we can signal that with our Linux terminals by pressing Control D, but you can also do that via having the input finish in some other way. But for the moment, we're just going to use standard input and Control D. Right. So if we did want to read in multiple characters, if we want to do something like a loop like this, we can have a getChar here, so this is a loop that sets itself up in the beginning with a character by reading one in, and then after that it keeps reading in characters. So this is a different loop structure than we've been using before, right? So before we were counting how many times we're doing things, or we were flicking a flag to finish. Now what we're kind of doing is we're saying, I'm going to call this function, and that's my iteration of my variable that I'm looping on here, and I'm going to say that until this variable says that they've read end of file, I'm going to keep reading more variables. So this function here reads in a variable, and then it prints out, I read a certain character with a certain ASCII code, and it's just going to keep looping. So one of the interesting things we could do with code like this is we could run it, and we could type enter or space and stuff like that, and this thing would be able to tell us what ASCII codes there are for things. So it's an interesting little bit of code to run. I'll show that later, and I'll show when we're working with strings as well. We'll work with characters and strings as we go. The question was, is EOF a variable? EOF is not a variable. EOF is a constant, though. So it's literally in the standard input-output library. There's hash define EOF to a particular value. I can't remember whether that value is 0 or -1. We could actually test that if we want to. But it's a specific value, but it's a constant, so we can't make changes to EOF. And the clue to it being a constant is it's all capitals. In the same way that we've been following that convention, every time we did a hash-defined constant, we've been using all caps. EOF follows that same convention. Oh, it's a -1. Thank you. Yeah, I knew it was one of those. Yeah. Someone's asking if I considered setting up a Windows subsystem for Linux. I don't usually use Windows subsystem for Linux. Personally, what I would usually do is actually dual boot to have a full Linux operating system. The other option is I might set up a virtual machine for Linux, but I've never actually tried the Windows subsystem for Linux. Maybe I'll try it. Anyway, we're actually over time on the lecture today already, so I should wrap this up. There's a library that we can include in the same way that we can include standard input output, and I showed you before that we could include things like math.h and standardlib.h and things like that. We haven't really gone that deep into libraries, but now we can. And there's one called ctype.h, which has some nice little things that we can use to, say, take a character, and see it here, even with the individual characters, we're using them as integers. To say whether something is upper or lowercase, we can convert something to upper or lowercase. We can ask whether something is an alphabet or is a digit and stuff like that. So if you want to, you can look up ctype.h and get some information about these little functions. A lot of them are going to make parts of your coding easier, and it's nice to sort of know what things you can get for free when you want to use them. Okay, so I should wrap up for today. So some things that we looked at today, we actually spent heaps of time on pointers recap and finishing the program for pointers, but I think that's a good thing because pointers is one of those things that's very, very hard to understand. So I think it was worth us spending some time on that. We looked at debugging and we looked at what the idea of syntax and logical errors are. We didn't get into the actual debugging and testing, but I'm going to make sure I do that separately so that we have that information available for you. So I'll do that as a video. See if I've got time tonight. Tonight I might be prepping tomorrow's lecture, so it might be later in the week. But I do want to make sure that we go through a debugging example. And we also had our first look at characters. Oops. Gonna move that out of the way so that disappears. Characters being variables that represent letters. So those now allow us to start looking at letters on our keyboard and stuff like that as things we can use in our programs. So I'm going to... the question was, can we enter sentences while using getchar? Yeah, you can. So if you're looping getchar multiple times, you can type a whole sentence into your standard input and press enter. Usually once you press enter, all of those characters will go in, and if you're looping getchar multiple times, it will grab them all in order, one after the other, and do something with them. So yeah, we're definitely going to be able to doing stuff like that. Yeah, and whoever that is there called me, at least now I'm recording, and so it doesn't get cut off at 5 minutes to the hour, which is bad because I just kind of stretched an extra 10 minutes on the end here, so I apologize if everyone wants to go. We're wrapping it up here, but if you have any questions that you want to ask still, stick around. But in terms of official content, we are finished here, and I'll just stick around and answer a few questions if there are questions in the chat. Okay, so let me I'll just switch to another slide so you know that the lecture itself is done. So we have a question here from Outdoor. So one of the issues that I've got is, like, I don't know who's asking me the questions because I don't necessarily know what your names are or anything like that. I'm not going to say that you have to put a photo of yourself and your name in there, but if you want to, it would be handy. Anyway, the question is the final exam just coding, or is theory also covered? Like, for example, all of the bytes and bits stuff. There's a bit of both. So there will definitely be some theoretical questions. So there'll be some things which are asking you things like, what am I... I was just thinking of questions, but they're questions on things I haven't taught you yet. There might be some theoretical things. I don't know if we're necessarily going to ask something as trivial or silly as like, how many bits are there in a byte? I'm like, that's a dumb question. It's nice for you to know, but I don't want you to have to memorize random things like that. But it might be more along the lines of, here's some code. Can you tell me what's wrong with it? And then you've got to go through and sort of go, all right, this code appears to want to do something, but it's doing something else. So we might test your understanding of things, rather than like, uh, how many bits are there in an integer? And you'll be like, well, this really depends on your compiler and stuff like that, right? So we're not necessarily going to be asking you trivial theory stuff, but it might be like, we might be testing whether you can understand code and concepts and stuff like that as well. The question also was, the exam takes place through the terminal. Yeah. So it's not necessarily through the terminal, but it's a whole environment. So what we will do, and honestly, the fact that I'm here at home talking about this right now means this could all be up in the air. We haven't yet had the proper discussion with the school about how we're doing exams, because honestly, we got the call to take everything online less than 24 hours ago. So we we at at COMP1511 had thought that something was going to happen already. So we'd sort of started preparing the possibility of teaching the class online, but the idea of taking the exams online, we haven't really even gotten there yet. We're thinking about a few different options. Um, but I'm going to talk about the exam as if it was going to plan the way that I had planned it at the start of term, which is, um, we you go into the labs for the exam, you log into the computers, but you don't go to log into your own account. You will get logged into a special exam account, and that thing will be specifically limited, so you can't just open Google and do things, and it will have the questions there in particular setups. So the theory questions, you'll actually have like basically a form which has the questions and you fill in the answers. The practical questions will act very much like a lab, where it will be, you'll get given a question on something very similar to your labs, like an HTML or a PDF, and then you go into your files, you change them, you auto test them, you submit them, that kind of thing. I'm going to do a whole lecture about the exam later in term anyway, so I will teach you all about that later. The question was, how long is this term going to be? We're trying to simulate the exact same term that we were going to do, but doing it all remotely. So the same number of lectures, I'm going to use exactly the same lecture plan, same slides and stuff, except I'm here at home instead of being with you in the lecture theatre, so that none of us can infect each other. But we're going to do the same exact 10 weeks, which means next week is actually the flexibility week, where we won't have any official content, no accessible content, but I'm going to deliver some content anyway, because there's stuff I want to teach you which may not be in the exam, but I think is still pretty important. So we're going to be doing that kind of thing. Question there. Do we need to know how to navigate a system using the command line interface? I think that would be a good thing for you to know. But if we're talking about, do you need this for the exam environment, the exam environment will still be in a windowed Linux system. So if I remember correctly, you can still open the file explorer and stuff like that, and then drag around folders if you need. I would say it's good. It's definitely good to know how to use a command line interface, because depending on where you end up working or what kind of research you end up doing after UNSW, plenty of them use command line interfaces, especially when we do custom stuff. So a lot of the time, companies will use Linux distributions that are heavily modified for their work, and so these heavily modified Linux distributions will often have some things that only work via command line interface. So it really depends on what you do, because there's plenty of jobs out there for people who do computing, that won't even do code. So like, I think there's a good 30% at least, 30-40% of the computing industry who literally don't code. Um, they they do things like when you look at the QA engineer there that I was showing before, they make sure that the stuff the coders are writing has been tested really thoroughly before we throw it out into the public, or for example, before we put it inside a building as a security system, not knowing that there was a massive security flaw. That's why we pay QA engineers so much money to do stuff like that. There's also other people who like you may have heard of the term product manager, where it's the person who stands in for the user in a sense to make sure that we stay on target for product. So we have a product we want to release, and we've got a lot of coders working on that product. We need to make sure that the coders don't do stuff that they think is cool that doesn't match the product. So that's why you have a product manager, kind of keeping us on track for that kind of thing. Um, Another question, going back to the exam because I was rambling there. Will we be able to simulate the exam environment before the exam itself? Yes. We actually have, well, okay. Usually, yes. this whole this whole taking the entire course remote. You may be able to tell that I'm a bit more stressed than usual today. That I'm a bit like whoa because it's been a bit full on the whole weekend. Um, uh, Usually we have a lab where we actually log you into the exam environment. So it's usually the very last lab of term where we go, okay, here's the exam environment. This is exactly what it's going to be like. And we actually show you some of the questions from last year or the previous year's exams. We go, this is exactly the kinds of questions we're going to ask you, and this is the format and stuff. And so you've got some familiarity with it. With us going 100% online, we have more questions that we will have to answer from our end of the course to make sure that you have a fair run into the exam. Um, we haven't sorted all of that out yet, I have to be honest, but there's things that we're going to work on to make sure that's okay. Um, we'll have to figure out exactly what format the exam's going to be first, and then we'll have that kind of lab. And so if everything goes well, and Australia kind of does very well with the coronavirus, then we're going to be a few weeks and then we'll potentially be able to be back in labs and stuff like that. I probably won't bring the lectures back this term because putting 500 people together in a room is just a very, very silly idea at this point, and I don't really want to be. I don't want to be like, hey, COMP1511 was ground zero for an outbreak, right? I really don't want that to happen. So what we will be doing is figuring out what we can do in person and what we can do online. And the exam is something that I will have to have discussions with my superiors at CSE and figure out what our plan is for all of the CSE exams and stuff like that. So leave it with me. I will get back to you about it sooner or later. Lawrence is asking, is everything after this week remote? As of now, yes. Everything is remote until we say otherwise. So all of your tutorials and labs for this week and continuing are going to be on a system that we're using called Blackboard Collaborate, which is a system that the university has for teaching online courses. So it's already been tested for online courses. Hopefully it works okay. But I mean, honestly, I'm just going to apologize in advance because we haven't used it that much, and unlike the the teachers who have trained for online teaching and have trained in this, we kind of dropped the tutors in at short notice, and so we're hoping everything works out okay. If you have any problems with it, if there are any issues, let us know. You can ping us on the forums, or you can email the CS1511 address if there's any really pressing issues. We'll try to do our best with it. But at the moment, the thing we're most concerned about is not allowing this pandemic to like spread easily. So we're just separating ourselves. General advice: don't touch anyone. Wash your hands regularly. Only hang out with people in person if you really, really have to. I mean, this isn't my advice. This is like World Health Organization stuff. And hope that we can kind of contain this early. But yeah, so here at Comp1511, we're going to try to do our part by making everything remote. Yeah, thank you for the consideration, Abiram, because It was very short notice. At least we thought that something like this might happen, so we started preparing over the weekend. And then when I saw stuff like photos of people in hazmat suits out on campus at UNSW, I was going, oh my god, we're in a serious situation here. And so I was kind of happy that UNSW reacted pretty quickly. I mean, I knew that they were only going to react during office hours, but they reacted really quickly on Monday morning to say, yep, okay, we've got to do something about this. And so they sent it out to all of us saying, can you go remote? If you can go remote, could you do it as soon as possible? So we thought we could do it today, and I think we've done okay so far, so we'll see how it goes. Okay, I should wrap it up there because we're a bit over time in the lecture now. So actually, let me just see if, because there's still heaps of people here. Does anyone have any further questions? If you have any further questions, type them into chat now and I'll answer them. Otherwise, this would be like normal than me leaving the lecture theatre and going back to my office. Except my office is now just the room in my apartment instead. So I'll just give you a couple of seconds for anyone to ask any final questions, and I'll answer them before signing off. Okay, looks like no one has any more questions. Thank you all for coming today. Hopefully this format still works for everyone. If you have any issues with the remote format, I mean, like, for example, that he couldn't do any live coding because it wasn't working. Don't worry, that's an issue I know about. I'll do something about that. But if there are any other issues, especially if you have any issues with not being able to stream because the internet connection isn't good enough where you are or anything like that, please let me know and I'll do what I can to help. Oh, we do have one question. Okay, I was about to sign off. Go for it, Alex. It might be a long question. Then Alex is just typing it in. I feel like I have to fill the space. No, there we go. Okay, if we have a function that you made that typically requires a scanf, can you import your own values from inside the function regardless of the user's input? Um, let's see if I fully understand what you're asking there. So you're saying if we have a function that would normally be taking user input and you wanted to disregard the user's input and replace it with something else, I can definitely think of a way to write that code. So you could actually scanf into a variable and ignore that variable from then on. So if you really wanted to, you could, yeah, just go, I'm going to scanf your input. I'm just going to keep scanfing your input to a certain number of characters or something like that, and write it all to the same variable, and then never use that variable to effectively throw it away. And you could also write some code that says every time the user types in a letter, I'm going to replace it with this other letter instead. So I could definitely see you being able to write a function that every time a user typed a letter, it would put an X into an array instead of that letter. You could do something like that. So there's definitely a way, but I'm not sure if that's exactly what you're asking, but hopefully it was. There's another question for getchar. Do you do scanf? Getchar and scanf are completely different things. Getchar can, to a certain extent, replace scanf, but it's a little bit different because scanf is saying, I will look at what the user typed in, see if it matches a particular pattern, and then put it into a variable. Getchar will say, I'm going to take one character at a time. So if I did scanf for the number 1 million, it would just read that whole number and put it into a variable. If I getchar of the number 1 million, I will get the character 1 then the character 0, then the character 0, etc. for all the zeros. So getChar and scanf work a little differently like that. Scanf is a little bit more abstract in a sense, where it goes, oh, I could read any number of characters so long as they meet this pattern that I know. Whereas getChar is like, nah, one character at a time specifically, and we'll read them into arrays usually, and then deal with them afterwards. Can we use what we learnt today in our assignment, like the end of file things? Yes, you can use stuff in the assignment if you need. You don't need characters in the assignment at all. So I would think that if you were going to start doing stuff with characters, it might complicate things. But if you really wanted to, you could use getChar for the input in the assignment. But I haven't actually taught you yet how to convert a character back into a number. So for example, the number 5 doesn't have the value 5 if it's a character. It has its ASCII value, which is not actually the integer 5. So be careful about that kind of stuff. I would say don't bother using getChar or characters or anything like that for the assignment. The assignment was designed with scanf%d in mind, because it's much easier to do with scanf%d. It's actually a bit more complicated doing it with getChar. But reading to the end of something like EOF, yeah, because we actually taught that last week. Was it last week or even the week before? We taught reading in numbers and Control D. So if you want to look at the EOF stuff, you can definitely just go back to the lab and tutorial from last week and go, oh, where are the stuff with the Control D in it, and go back over those exercises. They should help you a little bit for, say, reading in the mines in stage 1 in the assignment. Okay, Alex is continuing. For example, could you make a while loop that inputs into a function which usually scans input? I get what you're asking now, Alex. Is if you have a function somewhere that usually does scanf, but you want to give it some information from somewhere else in the code, we can't necessarily do that. But what we can do is we can change the way our code runs. So if a scanf was usually going to be writing into a variable, which it usually does, right? Because that's basically what scanf does. We give it the address of a variable and it writes into that variable. What we could do is in our code somewhere we've got an if statement that says, am I going to take the user's thing or am I going to take the program's thing? And you say, if I'm going to take the user's thing, I run one function, which does the scanf. If I'm going to take the program's thing, I will run a different function, and that different function doesn't scanf, and instead it writes certain information into that variable. So instead of just trying to pass something to a scanf that exists in the code, we can cut that scanf out of the code and go straight to the variable that it was going to write to. And you can kind of see already how we would write that code. Question was, who marks challenges? It depends which challenges you're talking about. So there's challenges like the random stuff I throw in the lectures. No one marks that. That's me just saying, here's something that's really interesting that you could look into if you want to. So I did them on a lot of the earlier examples. Yeah, no worries, Alex. And in terms of lab challenges, the lab. Oh, right, we're talking about Hall of Fame. So assignment Hall of Fame. That's going to go to myself, Tom, the subject admin, and we'll probably share it with all of the tutors, because what we're going to do is we're going to show a few of those things. They're not really marked. I mean, they're marked as in MARC marked, where usually everyone that submits something to the Hall of Fame, I will look at it. This is usually much later. It's actually after the term finishes, because I don't really have time during term. I'm pretty busy. But afterwards, I will look at the Hall of Fame stuff, and then I will say, look at your code and look what you did, and I'll send you an email back saying something like, hey, this is really cool, I really like what you did here. And then sometimes, just for the fun of it, I'll throw you further challenges. I'll be like, hey, that's cool, you did this, have you considered extending it to this, and stuff. So stuff like that. So it's not really marked, but I will give you feedback, and everyone that emails us something in a Hall of Fame will give some kind of feedback too. Okay. There's oh my god, he is cute. Okay, we're gonna finish on that. That's where we're gonna finish. All right. Also, we've gone way over time, so I'm going to wrap it up there. Thank you, everyone, and thank you, everyone, for dealing with the fact that this is remote now. Although I'm sure there's plenty of people there who said I just removed my commute from my Tuesdays, so I'm pretty happy about this. So hopefully that's the way everyone's approaching this: is that yes, we have to go into lockdown. We have to try not to infect people or carry the virus around, but we can at least make the best of this situation. So I definitely woke up later today, and I was happy to not have to commute in the morning rush. And I hope that we can take the positives out of that while we stay at home for the next few weeks and don't go anywhere. Yeah, cool. All right, I'm going to wrap it up there. Thank you very much, everyone. I will see you tomorrow. We'll start the stream at 11 a.m. tomorrow. It'll be reasonably similar to this, but hopefully I'll have something set up so I can actually show you code then. Okay, see you later.